Good morning to all. Today we are starting the new series, circuit design series, and this is part 1. In this we are going to see the circuit where a push button is there, and if you push that button, the circuit will on. So what will be this kind of circuitry? We will just overlook, and we try our best to have the kind of circuit where power supply will be there, intermittent battery in the circuit that requires supply from the battery. How it will be as a soft push to on circuitry will be there. So it is based on the one MOSFET. We start with some basic circuit arrangement, then we gradually come up to the what we required. Okay, so this is basic circuitry where p-channel MOSFET is used. This side is power supply, assumed to be 5 volt. This is the P channel and this is switch. So we consider this is as circuitry. Okay, so when the switch is closed, the ground goes to the gate of the PMOS, so it will close the path between source and drain, so the light will be glow on. But when the switch is not pressed, so the gate of the MOSFET is floating, so to keep that a constant at high voltage, we just put a one resistor here like this. Okay, so when switch is not pressed, the high voltage present on the gate, so the switch PMOS, once we switch press, the gate of the MOSFET is 0, so it will switch on this path, or we can say that the MOSFET will close the source and drain terminals like that. So after we get the supply here, so assume to be there is one circuit microcontroller based or anything that has some port pin which can be pull this gate for the 0. So we can use the some transistor there like this. So when there is a push of this button, we get the power supply to the circuit, and there is one microcontroller or any other circuitry which will make this transistor on. So even though we release this button, still we can get the ground at this point using this transistor, either by microcontroller or any other circuitry. Okay, in this way we can have the push to on circuit arrangement. So we are very much concerned about the structural values of the circuitry. So for practical purpose, you can refer the actual values by calculations. Okay, so for the basic thing, I am saying that this is structural logical verified circuit. Okay, so if we are not using any microcontroller, then we can have the simple PNP transistor. When the switches get closed, we get the ground here, and due to the ground, the this Q5 will be on, and the whatever the supply here, it comes to this transistor base, so it will on, and always keep this point as a ground. Okay, so in this way we can have the push to on circuit arrangement. We can see the simulation in the Protus one by one. Okay, so this is our simulation setup for the Protus. We just run on. This is a simple Protus setup. We just run this. As we press this switch, it will on the circuitry. Okay, so but when I release the button, it will not continuously on. So we need some circuitry here so that it will keep this point always 0 after release, even though we release the switch. So for that we just add some circuitry here as we told in the presentation. Just switch on the supply. So once we switch on this, and even though we release it, still we get the supply. So in this way we can have the push to on circuit arrangement. So we move back to our presentations for the further details. So if we are consider this arrangement for the intermittent battery charging setup, like this is our earlier discussed circuitry, and this is a battery setup. This is our battery to circuit arrangement. This is the same circuitry that we discussed. So we are using two circuit arrangement here, one from supply to battery, then battery to circuit. So once we close this switch, the transistor, both transistor collector point goes to the 0, and or we can say that the MOSFET, both MOSFET gates goes to the ground or 0 potential. So it will switch on the both the T1 and T2. Okay, so it will connect supply to the battery and battery supply to the circuitry. Once we get the supply from at this point, after closing of this switch, there will be some microcontroller which will just make one arrangement that once it is on, it will make this point or make this battery to circuit point equal to 1, or and as well as the power supply to battery port 1. So as soon as the microcontroller on, these two pins, it will make sure that it will on. Okay, and once it will read the ADC values or battery values, on the depending on the supply at the battery, it will make this T1 on or off using this terminal or this port using this microcontroller. So in this way we can have the soft switch on circuit arrangement, and as well as we can control the battery either from the microcontroller, or we can use some comparator to have that arrangement to charge the, this is a reference, V reference. Either you use some voltage divider network or potentiometer to set this one. So it will continuously monitor the battery and switch on off T1 for the charging purpose. Or we can use the microcontroller to read this battery voltage from this divider network and make the T1 on or off. Even though we can have the another switch which can bring this soft off as well. Once we press this switch, it will switch off the T2 by using this battery to circuit point as equal to 0. So it goes to the off, and the supply to the gate equals to 1. So this T2 will be off. In that case, we can have the soft on and soft off using the microcontroller as well. So I hope you get this basic circuitry, and please subscribe my channel and be with me so that we can have the long journey of the circuit design. So it is just start. Okay, thank you.